6.1 Slope fields and differential equations. Slope fields are the small little hash marks that represent what the slope would look like at the lattice points, as they call them. So if they're saying the derivative is negative x, this x is 1, so I got to do negative 1 when I plug it in, so I draw a little hash mark that has a slope of negative 1. That also has an x of 1, negative 1, negative 1, negative 1. Here x is 0, so negative 0. When I draw a line that has a slope of 0, it looks like that. Here all of these are x's of negative 1, so negative, negative 1. I plug in and I get 1, so I draw a slope of 1. Question 2 says find the general solution of the differential equation. Here's a derivative. General solution means find the original. So I'm going to do the antiderivative. Add 1, multiply by the reciprocal. Cosine, I know it's some sort of sine. If I take the derivative of sine, I get cosine. Adding negative cosine is what's minus. What is the antiderivative of 1 over x? It is ln, absolute value of x, and then I need the plus c. So that is a general solution. That's what that means. Solve the initial value differential equation problem means find the equation y equals. That satisfies all of these things. As this is the derivative, it's 6 when x is 0, and its derivative is 1 when x is 0. So first thing I do is I go back a step. If I go take the antiderivative of the second derivative, I get the first derivative. Antiderivative of sine is some sort of cosine. I never remember, so I just take the derivative. Derivative of cosine is negative sine, not what I want, so I need negative cosine plus c. I need to find out what that c value is before I go, so I use the fact that, alright, when x is 0, I know the derivative is 1, so I'm going to plug that in here. Derivative is 1 when x is 0. Trig at 0, function point is 1, 0, so cosine is the x, so I've got 1. So that c is 2. So I'm going to go back up here. I'm going to rewrite it, and I know the derivative is negative cosine x plus 2. I don't want to know the derivative. I want to know the actual original equation. So I'm going to do that process again. And I'd go backwards and find y equals antiderivative of negative cosine. If it's sine, derivative of sine is cosine. I don't want cosine. I want negative cosine. Antiderivative of 2 is 2x. And then I need the plus c. Alright, well I know that when x is 0, y is 6, so I can plug those in. 6 equals negative sine of 0 plus 2 times 0 plus c. 6 equals sine of 0 is 0, 2 times 0 is that, so c is 6. I plugged it into here, so then I need to go back in there and plug in my new c value that I know is 6. This is the one equation that passes through that point, has a slope of 1 when x is 0, and has that as a second derivative. Keep going. Essentially solve the differential equation again. In order for me to go backwards here, before I do that, I need to do separation of variables. My thought process is I multiply the 4y over, I leave the dy, I multiply the dx over. Now we take the integral of both sides, add 1, to multiply by the reciprocal, add 1, multiply by the reciprocal, plus c. It's up to you whether you want to plug that stuff in now or solve a little bit. I solved a little bit first. I divided everything by 2. So I got 1/4 x squared plus a different constant. I'm going to plug that in right now. Y is 2 when x is 0. So y is 2, so 2 squared is 4. X is 0, we get 0. So c is 4. I'm going to plug that in. Solve for y. Y technically is plus or minus the square root of 1/4 x squared plus 4. Which one do I want? Well, since y was positive, I need the positive one. That was your answer for number 4. Down here, the matching. Sine x, if I plug in 0, I'm going to get sine of 0 is 0. So wherever x is 0, I need a 0. Little slope line. So A and D are out, that leaves C and B. Definitely it is C because that matches the trig antiderivatives going on there. Here we've got y minus x, so if I plug in 0, 0, 0, 0 is going to give me 0. If I go to 1, 1, I also get 0, 2, 2, I also get 0, and so on. So that means that one is D. 2 minus y. So a lot of times I think about where does that equal 0, because I can see where those little hash marks are level. So y equals 2. So I can see that that one is A. Y equal derivative is x. So there's 0 when x is 0, I have horizontal. There I've got the 1s when x is 1, and so on. So that one is B.